Okay, now let's look at the PIV derivation for the bridge rectifier circuit here. So now let's look at the PIV, okay, for the bridge rectifier circuit. Now if you look here, this is the circuit, and again we let's look at the positive half cycle. Okay, V against T. So let's do this. So it means that this will be this will be positive, this will be negative, right? So what will happen is current will flow through here and through here. So D1 will be on, D2 will be on, D4 will be off, and D3 will be off. So let's look at the PIV for D4. Let's calculate for D4. If you assume all the diodes are the same in terms of the characteristic, having the same V gamma, so if you got the PIV for D4, it will be the same for the rest of the diodes. Okay, now so we have D4 over here. Now so to simplify, in order to get the PIV, we're going to do a KVL in this loop. Okay, we're going to do KVL at that loop, okay, because you have a D4 over there. So if I redraw this circuit again, it will look something like this. You have the V out here, and we have this is where we want to find the PIV, right, the peak inverse voltage. And then you have the D2. Okay, now, and then the polarity of the, because this is positive over here, negative over here, it will be positive, negative of the peak inverse voltage, and this will be your V out. Okay, V out goes across the resistor there, and also you have D2. So if we do a KVL, what we'll get is, we get the starting from there, so we do a KVL, so we get plus PIV, then you assume there's a current, okay, because there's a resistor here, there's a current that goes to R, so we plus, so this is plus, this is minus, V out, and then so D2, don't forget D2, we have across D2 is V gamma, don't forget. Yellow not very good. Okay, so then plus V gamma equals to 0. Okay, that's a KVL. So PIV equals to minus V out minus V gamma. Okay, right, let's pause for a second. Okay, let's continue here. So PIV equals to minus V out minus V gamma. So let's do some maths here. So let's bring out the negative, so it will be V out plus V gamma, right, minus times in bracket V out plus V gamma equals to PIV. Now we need to find the value of V out. Okay, we need to use another page. Okay, here, let's do it. So what's the, now what is V out? V out is actually the voltage across the resistor here, right? If I redraw this circuit over here, it will be like this, and it will be like this. Okay, so don't forget the voltage across here, the voltage across the resistor here is due to the current times the resistance. So if I redraw the circuit again, Then this goes to VS peak, right? So because we are looking at the VS peak. Oops, let's connect the circuit here. I don't know why it doesn't want to connect. Okay. Let me rub off this bit here. Okay, so disconnect to here, right? So the maximum voltage that you can have across the resistor here is the voltage here. So they say this is VS peak, it will be here. Okay, doesn't want to work. So you have, I don't know why. Oh, sorry. So now the voltage here is VS peak. Let's say there's no drop over here, so the voltage here will be VS peak minus 2V gamma, right? Remember from our previous class, the V out, we've done this derivation before. V out equals to VS peak minus 2V gamma. So we can substitute back to our KVL just now, and it will be, what's the value? Peak inverse voltage equals to minus V out, which is VS peak minus 2V gamma plus V gamma. Okay, so if you open this, it will be minus VS peak minus VS peak minus V gamma. Okay, so since the PIV is the inverse of the voltage, so we just do the modulus of this, and you will get the value to be peak inverse voltage to be S peak. Am I correct? Oh, sorry, there's a mistake here. So this should be plus. Okay, so this should be plus. So if you take the modulus, and we know the VS peak is a bigger number, then V gamma is 0.7. VS peak normally is greater. You can have 12, you can have 200 volts VS peak. So if you take the modulus of that, it will be, and want the positive value, so we have VS peak minus V gamma. We just multiply both ends with negative. So that's how you get the peak inverse voltage for the bridge. So let's say if it is difficult for you to derive, then my advice to you is to memorize the equation. But if you can derive, or you find other videos that are easier to derive, then it's good to know how to derive in case you get blank in the exam. Okay, all right, thank you. I think that's all for today. Okay, see you.